This video is about the evidence that has been collected to explain the idea that the universe is expanding. To begin with, though, I'll describe to you how we evolved the idea of our solar system. In the past, we believed in the geocentric model of the universe. Aristotle, an incredibly brilliant Greek philosopher, decided that because he could not feel himself moving, that the humans and the earth must be at the centre of the universe, and all other objects must rotate around us. However, this model became incredibly difficult to actually justify, and some people, including Nicholas Copernicus and later Johannes Kepler, believed that actually the Earth was not at the centre of the solar system, and their model was much simpler and easier to understand. However, it was not until Galileo came along, and using evidence collected using his telescopes, that the model was adopted more across the whole of the world. The same issues have been going on since time immemorial about the universe. The traditional and accepted idea was that the universe was infinitely old and not changing. This was called the static universe. A new, more controversial idea was that the universe was not infinite in age, but finite, and was continuously changing. Many scientists, philosophers, and even writers asked questions about which method or model was correct. Thomas Digges, Johannes Kepler, Edmund Halley, Jean-Philippe Javot, and even Edgar Allan Poe asked questions based on this. But the most famous one was created by Heinrich Wilhelm Olber. He asked the question, why is the sky dark at night? He considered this to be a paradox, because if the universe was infinitely old, not changing, and full of an infinite number of stars. If you ask someone to explain why it's bright in the daytime, they will say to you that the sunlight from the sun makes the sky bright. However, if you believe the universe is static, you also must accept that the night time should also be bright as well, because an infinite number of stars have been sending light towards the Earth over an infinite amount of time. Therefore, it should be bright, not dark. Hence, Olber's paradox. The evidence collected to disprove the idea of the static universe starts with something called the Doppler effect. The Doppler effect is about objects which emit sound waves. A stationary object emitting a sound wave of constant wavelength will sound the same as long as everyone involved is not moving. However, once objects start to move, the wavelength of the sound wave is actually altered, and that change in wavelength of the sound wave tells us about the motion or the relative motion of the object emitting the sound. A classic example of this is a fire engine travelling along a road. The fire engine emits a sound wave of constant wavelength, yet the sound wave is apparently changed by the motion of the object relative to us. As we could hear, when the fire engine was moving towards us, the sound wave was high-pitched, and when it was moving away from us, it was low-pitched. This can be explained by looking at the relative motion of the fire engine in comparison with the observer. When the fire engine is moving away from the observer, the sound waves were stretched out, making the wavelength larger and the frequency lower, hence a low-pitched sound. When the observer was in position and the object moved towards them, the sound waves are compressed or squashed together, making the wavelength smaller and the frequency bigger, which causes a higher pitched sound. If we looked at even faster moving objects, we would see that the effect is made even bigger. So an observer watching an object moving or hearing an object move away would hear a bigger change in pitch of sound as it moved away from them and towards them. If we consider this mathematically, we can say that the actual wavelength of the sound when the object relative to the observer is stationary, as lambda naught, and we use just lambda to describe the wavelength either moving away from us or towards us, then we can actually mathematically say that the change in wavelength, if it's negative, shows an object moving away from us, and if the object is moving towards us, then the change in wavelength is positive. Also, the larger the change in wavelength, we know that the motion, the relative motion of the object is also greater. This is described in the equation for redshift, or the Doppler effect. You subtract from the original wavelength of the object the observed wavelength, divide it by the true wavelength, and you know that is equal to v, the relative motion of the object, divided by the speed of light. Edwin Hubble used this idea for his observations of other galaxies from using his telescope. First of all, we see the spectrum of our own star, the Sun, and within that continuous spectrum we can see their absorption lines for the hydrogen which surrounds our star. It is a perfectly acceptable assumption, therefore, to make that all stars should have the same absorption spectrum that we see for our own star, the Sun. However, if we look at nearby galaxies, there is a small shift towards the larger wavelengths, the red light, hence the name redshift. And Hubble observed that the further away a galaxy was, the greater the change in wavelength. Hence, using the equation that I showed you earlier, Edwin Hubble was able to plot data relating the velocity of the galaxy relative to the Earth with the distance of that galaxy from the Earth. And he discovered that the further a galaxy was from the Earth, the faster it was moving away. This suggested that the universe was actually getting bigger, or more specifically, the space between galaxies was getting greater. Further to this, Hubble was able to estimate the age of the universe. If you calculate the gradient of the graph shown above, you see that we get a value which has a unit seconds to the -1. This is called the Hubble constant. It is a way of describing the rate of expansion of the universe. And the inverse of this Hubble constant also gives us an approximate age of the universe. Modern data suggests that this has a value of approximately 13.6 billion years. This evidence alone, though, was not enough to prove that the universe was not infinite in age or static. The killer blow came from the Bell Labs in New Jersey in 1964. Two research scientists, Arno Penzias and Robert Woodrow, had built a radio telescope. They were infuriated to discover that wherever they pointed their radio telescope, it picked up a faint microwave signal. The famous story goes that they thought that some pigeons who were living inside the horn were emitting radioactive poo, which had to be cleaned and removed from the telescope. However, even this did not solve the problem. Other scientists realised that what Penzias and Woodrow actually discovered was the signal from the beginning of the universe, where photons which had insufficient energy to become particles were left over, and they were now detecting them as they appeared today. As a consequence, we now believe that our universe is expanding, and, as we'll talk about in the future, that our universe has a finite age and is actually began around 13.6 billion years ago.